All right, let me just check if I am visible, if I'm audible, and then we will start. All right, I'll just check that. Okay, all right. Today we'll be learning about how we can actually classify something. Right, so this is going to be image classification. We'll learn how to classify things, and this is a really important part of like just machine learning itself. Now we'll be understanding how we can basically classify dogs or cats. Right, that's what we'll be doing. We'll try to see how successful are we at this. This might end today, this might end tomorrow, but yeah, we'll just get started right now. I'll just open up Google Colab. All right, I'll just open up Google Colab here, and we'll just open up IPython notebook, and we'll get started then. Now look, if you don't know what we'll be doing here, you can take a look at the previous live sessions in which I've talked about how basically machine learning works, right? So what is Google Colab, how it really works. We won't be discussing that right now, because right now we have a much important task, and that is to classify a dog and a cat, right? So we'll try to do that. Okay, first of all, we'll need to actually install a few things. So let's actually focus on doing that itself. So here, what we'll do is that we'll first of all, let me just check if everything is fine or not. All right, so first of all, let's get started. Let me just zoom in. Let's do full screen. Okay, so here what we'll do is that we'll try to create a model that would be able to classify and differentiate between a cat and a dog. Okay, that is what we'll be trying to do. Now, a few things to understand is that we'll be using something called as TensorFlow. Okay, so TensorFlow is a library in Python which enables you to very simply use the models, use some data sets, use some functions, and build out your model very easily, right? So then let's get started with that itself. First of all, what we'll do is that we'll just say something like this. We'll say import OS, we'll say import numpy as np, and we'll just say import. So here is something really important. We will just say keras.models. Keras.models, this should actually be this, from keras.models import sequential. So what is sequential? Sequential is just for us to create multiple networks, multiple layers of neural networks, right? So sequential just helps us with that. We can just say keras.sequential.dense, and then with that we can just justify what function will we be using, and that is how we will create our own neural network. All right, so I'll just do that. .models import sequential. Okay, then next we'll just say from keras.layers import, and in this case we'll be importing a few things. Number one is called as an activation function. You don't need to know what that really does. It's just a part of the complete model. And then we'll also get dropout, we'll get flatten. So these are just basically functions that we'll be using to make the data easy for us to understand. Okay, that's what we'll be doing. Then we'll also be using something called as keras.processing, keras.preprocessing actually. Preprocessing, that just basically means when we'll be taking the data and the image and we'll convert it into actual data. So what this means is that we'll be taking the RGB values of every single pixel and we'll try to convert it into something else, into data, but that we can actually use. So an example can be the RGB values are from 0 up till 255. We'll just divide all of the values by 255. So now we'll be having the numbers, the RGB values from 0 to 1. Okay, that is a better thing to do, just to simplify the process, right? Then we'll just say import image data generator. Okay, then what we'll do is that we'll just say from keras.layers import, and we'll say convolution 2D. convolution 2D. Now this is something called as a CNN, convolutional neural network. Don't worry too much about it. The names can be really difficult to understand, but it's a very simple process. We just reduce the dimensions so that it is easier for us to comprehend what all is happening and how can we use the data, right? So we say convolution 2D, then we say max pooling 2D, and then we'll just say zero padding 2D, right? So zero padding 2D. All right, next what we'll do is that we'll just say from Keras import optimizers. So these are just functions that we'll be using to basically optimize the functions that we have, right? The results that we are getting, we'll try to optimize that here. Okay, so that's what we'll try to do. After that, we will just say from keras.preprocessing import image. All right, let's just try to run this right now and see if there is any error. Okay, so there is no error right there. That's a good thing. Now what we'll do is that we'll try to get some sort of data, right? So this is the part that you need to figure out. How can you get this? So what we'll do is that number one, we'll be having something called as IMG width, right? We'll be having IMG width, and then we'll also have IMG height. Okay, and we'll just equate that to 150 into 150. That would just mean that every single image would now have a size of 150 into 150, right? And then we can just say train underscore data, and then we'll just call it that path. Okay, and here we'll need to provide the path. Where is the data actually located? So that would be a folder that we'll be having. That is what you can put into whatever whatever place the data is located. If you want to get the data, what you can do is that very simply just go to Kaggle. Okay, just go to Kaggle and just search for dog versus cats. Okay, and you'll get this page, and you just need to go here. Let's just see. Yeah, let's go into the data. Okay, so here in the data, what we'll do is that we'll try to download everything. So here we have the test, then we have the train as well. Okay, so we'll try to just download test, and we'll also try to download train. That's how you basically download it. It's about 800 MBs of data, as you can see over there. So that's what you need to understand. I won't be doing that right now, but you can do that. That's what you need to do. Then we'll just say validation underscore data underscore path. So you might be thinking, what is the difference between train data and then validation data? Well, basically, it's just a way for you to validate and understand how good is the model able to, predict or tell if this is a cat or if this is a dog. So first of all, we'll just train the data with train the model with labeled data, and then we will take this validation data and we will try to assess how good the model really is. Okay, that's what we'll try to do. All right, now the next part is going to be to basically like import everything that we have, right? Let me just run this. Next part would be to basically say that I want to something called as data gen. Okay, data gen is what it is called as, and we will just say image data generator, and we'll actually just say rescale is equals to, so here as you can see we're trying to rescale everything. Rescale is equal to 1 upon 255. Okay, then we have something called the train generator, and that would be equal to data gen dot flow from directory. Okay, this is a basically we give the directory location, then it goes into that place and it gets all the information, the data that it needs to get. Okay, so that's what you need to keep in mind here. So what we do here is that we will just say that flow from directory. Okay, and then instead of this we'll be providing a few things. First of all, we'll just provide the train underscore data path, and then we'll actually go back, and then what we do is that we'll try to provide We'll try to provide something else. Let me just see if everyone is there or not. All right, so yeah, in this what we'll do is that we will just say that first of all we want to have the trained data path, and then we say that we want to get the target size, right? So the target size is going to be target underscore size. Target underscore size is going to be equal to img underscore width, right? Img underscore width, img underscore height, and then we will just say that the next part would be the batch size, right? So batch size is what we'll be taking in. This is called as batching, right? So in batching, what happens is that we create multiple batches, and then we run the model through individual batches just to see what is the difference, what is the variance between every single time when we actually use this, right? So that's what we'll be trying to see here. Right, so next what we need to do is that we will just say batch size, and that would be equal to 32, right? So we'll actually be having, in every single batch we'll be having 32 of those images. Next one would be class mode, and that would be equal to simple binary. Right, so that's pretty much it. That's what we'll be doing here. Let's just try to run this and see if there is any error or not. Says class underscore mode. Class underscore mode is binary. Let me just check if there's any problem with this. Binary, I don't know if there's any error right there. Let's keep moving ahead. Let's see what other things we have here. Class mode. There is one more thing that we'll be doing, and that would be for the validation generator, right? For the validation generator, we will just say validation. So we'll say validation generator, that would be equal to datagen.flow from directory, flow from directory right there. We'll need to have validation path here, validation data path, and everything looks good. I don't think there's any changes here. Right, so after that what we'll do is that we'll just try to run this. There is any error I think, but we will try to fix that afterwards. The next part that we'll do is that, so far what we've done is that we have made a directory, a path where we have stored the image, and that path is just going to be a place in which you can find out what all images are there, right? So you can just download the images using this dog versus cat dataset on Kaggle, and then we can start using that from there. Or you can also just like copy this API command if you have the API, Kaggle API, right? So you can just search for Kaggle API here, just be like Kaggle API, okay, and you can start using that here. Let me just close this. All right, the next part would be, okay, so the error that this is actually giving is that there is no such thing as a directory over here, right? So what you would do is that currently I'm building this on my own, on this Google Colab. You would want to build it on your Visual Studio Code, and over there you can just justify, you can specify where the location actually is. So once you will download the complete repository that I showed you, the complete data set, then it would not show you this error, right? Because I have not specified the location over here. Right, let's just move ahead. And so here we'll actually start building the complete model itself. Okay, we'll start building the complete model. How does that happen? Well, first of all, we'll try to just say model, that would be equal to sequential. Okay, then we'll say model.add. Okay, model.add, we'll be adding convolution, right? So we'll be adding convolution 2D, and in this we'll be specifying what all do we want to add. So we want to have a batch size of 32, that is what we specified there. We want it to be 3, and then we want the input shape, right? So whatever image we are getting, the shape of that must be equal to img width. It's actually going to be this, yeah, img width comma height, right? And then we will also specify 3. Okay, the next part is going to be to basically just say model.add, and we'll add an activation function. And we'll put in what function do we want to use. So relu is what we'll be using, right? If you don't know what relu is, it basically is a way, it's just like a function. You can just search it up online. You can just find it over here. You can just say relu function, and you can go to like images and you can see how this thing works, right? This is how it actually works. And basically it's just like this. It is a condition which says if x is less than 0, then I want the value of the function to be 0 itself. But if the x is greater than 0, then I want it to be equal to x itself. That's what we want to do here. So that basically negates all the negative values that we are having. And there are just a bunch of these functions. You can just find them. There's also something called as sigmoid function that we'll see if we are using it over here. But basically you can start using these functions to basically, build your multiple hidden layers that you have, right? The next part, let's move on to the next part. And that would be to basically just say model.add, and here we'll be adding something called as max pooling. Okay, max pooling 2D. And here we'll just write the pool size. That would be equal to 2,2. Okay, moving on, what we'll be doing is that now we'll actually say model.add convolution 2D, and then we'll say 3233. All right, and after that, next what we do is that we will just say model.add, and here we'll just say again activation itself, right? So this is the next layer that we are having. This is the next layer. Basically, if you don't know how this works, is that we basically have multiple neural networks. So in every single neural network that we'll be using, we'll be having multiple layers, right? So each layer will give us more information about how this thing would actually perform. And we'll be putting in some operations. So in this case, again, we are using the relu operation. So relu function. So we can just put that right here. After that, we would actually be saying again model.add max pooling (2D), and that's going to be pretty much it. We'll just say pool underscore size, and that would be equal to 2,2. Right, so that's what is happening here. Let me just see. Yeah, looks good. After that, the next part would be to actually say something like this: model.add flatten. So basically what this function would do is that it would convert the values into like a logarithmic value, right? So if you just see like a logarithmic function here, let's just go to the images and I'll show you how that works. So it's basically like this, right? If you just see over here, the value is increasing, so it now looks like this. So this is what is sort of happening over here. Let's just move on to the next part, right? After this, once we are done with this, once we have flattened it, the next part that we'll be doing is that we would actually say, something like this. We'll say model.add dense, and then we'll say 64. Okay, then we'll say model.add activation. This is another layer that we are having. This is actually the third layer, right? So this is the third layer in the network that we are creating, the CNN, the convolution neural network that we are creating. Model.add dropout, and we are putting in 0.5. Let's move ahead. Next part would be another layer. So this is like the fourth layer that we are having, and in this case we are having something called a sigmoid, as I've shown you over there, right? So this is going to be 1. Then we'll just say model.add add something like an activation function right there. This one would have to be sigmoid. All right. After that, what you do is that if you can just try to run this, but it wouldn't really work because again there is some problem. Max pooling 2D is not defined. Max pooling, that's what we want to do. Run. The problem is going to be that it doesn't really exist, right? There's no such file over here. So let's move ahead. The next part is going to be the training itself, right? So we'll actually say this. We'll say model.compile, and we'll be putting in, first of all, a loss function, right? So loss function is going to be equal to binary cross entropy. Now we can talk about this in detail in some other class, but think of it just like a function that gives us how far away we are from the actual value, right? From the actual classification, cross entropy. And after that, we will just say optimizer is going to be equal to rm sprop. Okay, RMS prop. After that, we'll just say metrics, and that would be equal to accuracy. Right. Again, we can just run this, and then we will actually be doing some training. So let's try to do some training over here. We'll just say training. And in training, what we do is that we first of all define how many number of epochs do you want to have, right? So epochs are just cycles that we go through, right? So we will be revising through the same data set that we have multiple times to actually make the model better. So the epochs that we'll be having is going to be 10. Then we'll say NB training samples. NB train samples. This would be train samples. And that would be equal to 2048. And then we can just say NB validation samples. And that would be equal to 832. This is just basically the entries that they are doing, that okay, these many would be for training it, and this many would be for validating the actual value. Right. Let's just see. Let's go to the next one, and here we'll just say model.fit_generator, fit_generator. And in this, what we'll do is that we'll just first of all say that we want to have a train_generator. Okay, and then we want to have a validation generator and all that, right? So first of all, we will just say samples per epoch, right? So samples per epoch, and that would be equal to NB_train samples. NB_train samples. Okay, then the next part would be to basically just say NB epoch would be equal to NB epoch itself. Next part is going to be to say validation data, and this would be equal to validation generator. Validation generator. The next part is going to be this. We'll just say NB_value samples. Okay, with the validation samples, then that would be equal to NB validation samples right there. Okay, done with this. We'll just run this. It wouldn't really work because again, it is not really defined properly, so it wouldn't work because you need to actually get the data set first of all. But yeah, that's pretty much it. We are almost done here. We can also find what all weights and biases we are actually using, so that can also be found out. But what we can also do at the very end is that is just to evaluate how well we did. So here we'll say model.evaluate generator. So here we will actually put in validation generator, and then we will say NB underscore validation samples. Now this would not work right now because again, we need to have the data set first of all. So what I'll do is that I'll try to get the data set in the next class itself, and that way you can understand how this thing is actually behaving and working. But yeah, that's pretty much it. That's how you create a very simple CNN module and basically model that would predict if that particular thing is a dog or a cat. That's pretty much it. Thank you for joining me here for this class. I just want to quickly talk about Ask a Doubt feature that we recently added into the Unacademy platform itself, in which what you can do is that you can literally ask whatever doubt you have, right? So this is a great thing because a lot of times you might be having some doubts, but you might not be able to ask your doubts, and it's difficult to get the solution to the doubts online as well, right? So what you can do is that you can actually ask unlimited doubts using the Unacademy platform. It's very simple. You can just, go to this dashboard over here. You can just click on Ask a Doubt. You can put in whatever question you have, and you can upload a picture of that as well, and then you can get your doubts answered. Right now, let's talk about the Unacademy subscription. As you can see here, you would be able to learn from the comfort of your home. You would have some great teachers teaching you about whatever topic you have chosen, and it's a great way for you to learn and practice at the same time as well. Right, we'll be having some practice tests, we'll be having some test series, right, and you'll be able to ask whatever doubt you have as well, as I've showed you previously. Now you can also take a look at the batches that will be starting every single Monday on the topic that you want to learn, and this is the subscription for Unacademy. As you can see, this is the pricing for 1 month, 3 months, and subsequently number of months that you'll be taking in. Also, I want to quickly talk about what Iconic subscription is. This is basically a way for you to get a personal mentor that would actually teach you how everything works, right? So you can get someone to actually teach you personally, right? So that's what the Iconic subscription is for, and this is the pricing for that. And now you can also get 10% discount whenever you'll be signing up for the Iconic as well as for the Plus subscription by using the code ISHANYT10, right? So that's how you can get 10% discount. All right, now I just want to quickly talk about the scholarship test of Unacademy. It's called as Unacademy Combat, with which you'll be able to get a lot of scholarships to learn, basically, right? So you will also be having these revisathon series in which all of the topics will be revised for you, right? And yeah, you can also download the Unacademy app right there, and you can use the code ISHANYT10 again. That's pretty much it. This is Creative Corner. As you can see, you'll be able to learn a lot of things under the Creative Corner subscription. As you can see, we can learn about storytelling, Vedic mathematics, robotics, coding, negotiation. I personally have my own class on Python and web development as well, so you can take a look at that too.